All right. Hello, good to see you again. It's been a while since we've talked. So let's talk about multi-criteria decision making. We're going to have two brief lectures on this, and by brief I do mean at least 15 minutes because we do have a lot to talk about. But we're going to talk about what multi-criteria decision making is, and then we're going to talk through some examples of kind of what the theory is and how it works as we go forward. So when we start this lesson, what I like to do is I like to propose this question to the students or to you as the person watching the video. Which is the most important as an engineer? And here's a list of things: reducing costs, increasing sustainability, appropriateness of the design, reducing environmental impact, or preventing exposure to chemicals. Now, I personally would argue that these are all really important, but many times what our clients want us to do is they want us to simplify this down. They want a solid number. They want an answer, a number at the end of the day. The real world's really complicated. So what multi-criteria decision making is really about is about finding a way to honor all of these things, but to value and weigh them in ways such that we give value to every single one of these and we understand their importance to our client and how we're making decisions. So multi-criteria decision making is really about how do we make decisions. So here's another kind of option, and the thing to think about is we've got option one, option two. Option one is more expensive up front, but it's more environmentally friendly, but we didn't co-design anything with community stakeholders. Option two is cheaper up front, but it might have negative impacts on the environment, but we did work with the community, but there's still competing interest in the community that stalled out progress. And so neither of these scenarios is perfect, right? Neither of them looks really, really good compared to the other. Like there's pros and cons of each. And so what multi-criteria decision making is all about is understanding those pros and cons and saying, well, what needs to be weighed the most important to our client and how we're presenting our results. So multi-criteria decision making is really a complex interaction of multiple different things, and it's a way of trying to make sense of it. So what this particular slide is showing you is just the complex interactions that happen in the global environment and our regional environments between technology and who's using them and all sorts of factors. And multi-criteria decision making is really about how do we come to some kind of a conclusion based on the fact that we just live in a world where there's so much information these days. So you can kind of see here that it's just a complex interaction of many, many different things. There are so many things that happen in a system related to energy that we really need to think about where our boundaries are. So I'm sure you've started to hear this about LCA. Are we looking at the global environmental boundary? Are we looking at the regional environmental boundary? What are we looking at? So that's going to be an important first step in multi-criteria decision making. Right, so we've got all sorts of things happening in these types of systems where we might have to do multiple analyses that we've seen before. We might have to do risk assessment. We might have to do exposure assessment. We might have to do engineering economics, LCA, social dimensions. We might have to do all of these analysis for one client. And then they want some kind of a recommendation at the end of the day. And we need to balance all of those things out. So multi-criteria decision making is also about kind of honoring the fact that different analyses are meant to show different things, but coming up with some kind of a comprehensive answer moving forward. So this flowchart is not something that I want you to memorize. It's not something that it's critical that you know exactly every step in it, but it's an overview of what happens in a multi-criteria decision-making process. And what I want you to take away from this is maybe just pause it and read through it and take away the fact that there need to be many, many different steps. And the other thing that needs to happen is that we need to iterate through design. So if you take a look at this when you pause the video, you're going to see that we have to iterate. We have to bring those arrows back up to previous steps. And I think that that's a really important thing to take away from multi-criteria decision making, is that it's not a one-stop shop where you just go through the set of steps and you're done. It's a lot of iteration, it's a lot of conversation, and that's a really critical point. So basically, if we take that figure from your last slide and we slim it down into something that makes more sense, there are 4 big blocks that I want to hit when we talk about multi-criteria decision making. The first is selection criteria. what goes into actually selecting what you value in your multi-criteria decision making. Then there are a whole slew of weighing methods. How do you take those selection criteria like exposure assessment and LCA? How do you, from that selection criteria, how do you weigh those so that they matter? Then there are multiple different methods that exist for trying to put those weights into some kind of an equation. And then there's what's called an aggregation method, where basically we want to take all of this selection criteria and everything that we've done in these two steps over here, and we want to get an aggregate result. That could be an aggregate score, but it might not be. We don't have to score everything. We can actually have more qualitative data sometimes out of multi-criteria decision making. So in general, what we do when we talk about multi-criteria decision making is that we say, here's our criteria. Okay, this could be exposure assessment, this could be environmental impact, and then we apply weights to those in our particular system. And then most of the time when we're doing multi-criteria decision making, we are not looking at one system. We're looking at the difference between alternatives. That's why I showed you that slide with option 1, option 2. So we're going to have alternatives down the side. And so what that does is it basically generates a matrix, right? This is a mathematical way of showing what happens in multi-criteria decision making. We apply the weights to the criteria, and then we look at each of the alternatives under each criteria, and we basically get a matrix of results that allows us to compare every alternative at every criteria point. So this is just a mathematical way of showing you how that works out. So what comes first when we do multi-criteria decision making? It's a very complex analysis of the system, and we do a lot of analyses of the system. So somebody has gone and they've done LCA, or they've done environmental impact, or they've done whatever it is, exposure assessment. And then the actual multi-criteria decision making, the next thing that we do is define the system scope and goal. Like, what is the goal of looking at these multiple different things? We do a lot of talking to experts, right? We do a lot of weighing the results, we aggregate the results, and then we make decisions. So basically, we start out with all of these analyses that we've done. We want to figure out something based on those analyses. We have a question that we want to ask of those analyses. We go and we talk to people about this and get their opinions, and based on their opinions, we weigh all of our different results. We aggregate our numbers at the end of the day and make a decision. And that's multi-criteria decision making. So this is kind of just redoing that last slide so that they're in the right order, so that you know exactly what's going on, right? We start with just understanding the problem, analyzing, weighing, and aggregating. So kind of a repeat of the last slide. The goal is to make informed decisions out of this. So we don't want to have some kind of a decision-making matrix where we finish and we can't make an informed decision. That's not the goal, right? We need to be able to make decisions based on data. This is a very common issue that we see when we deal with clients as engineering consultants, because our clients have one idea of what they want, and they want us to help them make informed decisions about whether or not that is actually the best alternative. So I think this idea, again, of alternatives comes up here, where we need to be really, really informed about what decisions we're making. And it's just getting more and more complicated as we have more and more types of analyses that we need to do. So we really do need to be thoughtful with the types of analyses that we're doing. So the first step is defining your system goal and scope, and we're going to do this a lot with LCA. And basically the idea is that we want to know what we're evaluating, but the other thing that we want to know is what we're not evaluating. And that's really important. So sometimes we want to answer a question, but it wasn't in our goal and our scope. And so we have to go back and redefine our goal and our scope. And I think that this is really, really key as a young engineer, is to understand that if it's outside of your scope, you need to leave it outside of your scope. You can't answer questions with the wrong set of data, and that's really important. The other thing that we need to do first is we need to talk to experts. We need to talk to people who know the system that we're evaluating. So things like social dimensions, which we've talked about before. And then we need to talk to people who know how to perform the analyses. So many methods are very, very technical. They could use a second pair of eyes. So as an example from my own personal life, when I was working on my postdoc, we did multi-criteria decision making for 3 different analyses. We did exposure assessment, life cycle assessment, and costing. And I had not done any of those 3 in the past. So one of my first steps when working with my postdoc advisor was to talk to people from the EPA and from other universities who knew how to do these analyses so that I understood the best method to move forward with. So I can't emphasize that enough, that you're going to have experts when you get out into the field and you're working with other engineers who are going to know stuff that's really important to the type of analyses that you do. So talking to somebody who's an expert is really key. So the example that we're going to talk about in these slides is exactly the postdoc project that I worked on that I found was very interesting, and it's a very good example. So I just want to give you a little bit of feedback, a little bit of background on this particular project. So basically, in this project, we wanted to know whether it was better to use an upgrade to a centralized water treatment plant or to install what's called a point of use or point of entry device. And this is a drinking water example. So the theory is that in a small system, you're only going to have enough money to pay for something small up front. So it might be an upgrade to the centralized system, or you might want to have a point of entry system or a point of use system, because maybe that's going to better protect public health. And we didn't know which one was going to do a better job of that. And so that's really the question for us. And so we worked with, these are the different EPA regions in the United States. We worked with 4 different regions to try and look at this problem. So this is the example that I'm going to use as we talk through multi-criteria decision making, because it's a great example of, how do you really go through and weigh things. So what this shows you here is this shows you all the different alternatives that we were considering. So you can pause the slide and take a look at this in detail if it really interests you. But the main takeaway here that I want you to take is that we've got 4 different regions. And we looked at what they currently have for water treatment. And then we looked at an upgrade to their system. So this is alternative 1. And then we looked at one point of use or point of entry device here, so this is alternative 2, and then another point of use or point of entry device here, which is alternative 3. So you can see there's 3 different options that we're considering. So when we were looking at this project, we really wanted to understand the differences between these. So at this point, we haven't defined our criteria, we've just defined our alternatives. And that's important. You need to know what you're comparing before you can go anywhere. So then the next thing that we needed to do is choose our criteria in this project. And that's the next thing that you have to do in multi-criteria decision making. How are you going to evaluate those types of alternatives? So you need to figure out, what are the goals? What decision making goals do you have? We need to think about those alternatives, which we did, develop our criteria, and then figure out how we're going to score and possibly normalize those criteria as we go forward. So criteria are what you're evaluating, right? So what are some possible types of criteria? Maybe take a pause and think about, what types of criteria could we use to evaluate different alternatives in the system? And my hint here is that, what types of analyses have we talked about in this class? Because those could all be criteria. So just take a pause and take a couple notes and see if you can come up with some ideas. All right, so this comes from a paper that I've posted for you on Canvas, and these are multiple different types of criteria that you could use. It's very small on your screen, and I do apologize for that, so you can look at the paper if you need this a little bit bigger. But this comes from a paper where they looked at many different types of things and what the criteria could be. So let's say that we're looking at technical aspects of alternatives. Well, we might want to look at efficiency or energy use or safety or reliability. And then what's over here are some different papers that have used that criteria. So if you're interested in using that criteria, you can go look at those papers. So what this slide is showing you is that you really need to know what aspect of the project you're evaluating. Is it environmental? Is it economic? Is it social? And then what can you use to evaluate that thing? That's really what criteria selection is all about. How are you going to evaluate those aspects of your project? So there's methods for choosing criteria and how you actually do this. You can do it with what's called the systemic principle. So your criteria basically with this principle should affect or reflect, essential characteristics of the whole performance of the system. You can select criteria using what's called a consistency principle. So it should be consistent, the criteria should be consistent with whatever decision-making strategies you have or objectives you have. You can choose criteria using what's called an independency principle. So the criteria doesn't have a relationship with a different type of criteria, so they're independent of each other. That could be important to you. You can do measurability, so we need to be able to measure that criteria. Sometimes we have criteria that we want to do in a system, but we can't actually measure them. So measurability might be something important. And then comparability might be one that's important, right? We might be able to get the data for that criteria, but it might be really hard to compare criteria across alternatives. So these are some different methods for choosing different criteria. Just a way, it's basically a way of thinking about why would you choose the criteria you would choose. A lot of theory today. Hold on, we're almost there. A lot to talk about. Okay, so as the example for the point of use in the centralized water treatment example that we've been talking about, we used a form of what's called a triple bottom line approach. And the triple bottom line approach looks at three things. It looks at people, planet, and profit, 3 Ps. The other way that we can say this is that it looks at social or human impacts, it looks at environmental impacts in the planet, and it looks at economic impacts and profit. And the triple bottom line approach is very, very common and very, very popular when you're looking at sustainability and environmental impact assessments. So we decided that those were the 3 things that we really wanted to take a look at when it came to this specific project. So for us, what we decided to do is we decided to do what's over here on the left is called an exposure assessment. So that's how we wanted to look at how our alternatives were affecting people. Then we decided we wanted to use life cycle assessment to look at how things were impacting the environment. And then we did what was called a cost assessment or a life cycle costing to look at the economic impacts. So we basically said we wanted to understand 3 key things that our users are going to really care about. Its cost, its impacts on your health, and its impacts on the environment. And so those were the 3 things that we decided to include in our study. So the next thing that we had to do is the next thing that you do have to do when it comes to multi-criteria decision making, and you have to make sure that you understand your boundary conditions or your scope. So what you see here on this slide are some flow diagrams of the systems that we were considering. So on the left side, you're seeing in gray an existing centralized system. And what we decided to do was evaluate the upgrade, so adding another vessel to their system. And so these things in color on the left are the only things that were included in the analysis. We didn't include anything in gray, and that's important because then that's very comparable to integrating a new point of view system. So we only wanted to evaluate what was new to a system. And so we have to define our boundaries based on are they comparable? So that was really important to us in this particular study. We used the comparability principle to try and figure out where our boundaries were in this system. So then once you have your criterion, you need to figure out how to analyze it, right? So what method actually allows you to calculate that criterion? So for example, if you choose cost as your criterion, maybe your method of analysis is traditional engineering economics. All right, so it's going to be, what are you evaluating? That's the criteria. And then how you evaluate it is going to be the method of analysis going forward. So what analyses have you learned in this class that you could use to analyze criteria? Maybe take a pause and write down a couple that you can think of, and we'll discuss this when we get into lecture. So this is back to our example here of a triple bottom line approach looking at point of use and centralized. And here are the different improvements in this column here for 2 different regions. And you can see the time to implement, you can see all the different exposure numbers that we get here. So you can start to see that we've done some analysis. So we've actually done the analysis of exposure. If it's negative, it's good. If it's positive, it's bad. in this particular, I'm sorry, negative is good. No, sorry, positive is bad, right? Because it takes too many years to implement. Negative is good. It's green in this scenario. So this is just showing you that now that we know our criteria is human health impacts, we evaluated it using a calculation called average daily dose in the system. And so we can find a concentration and we can figure out what's going on in the system based on that. And then this shows some of the cost analysis that we did. So you can see that the analysis gets very, very rigorous, very, very quickly with these types of things. And so you have to know your criteria first, but then you have to be able to do the analysis. So this is where having experts really helps out in these particular types of systems. And then this is some results of our LCA. So now we have 3 different analyses, right? We've got 3 big things that we did. We looked at exposure, we looked at cost, and we looked at LCA. Now, if you look at the past 3 slides, that's pretty hard to make a decision based off of those 3. So that's going to lead us kind of into the next steps of what we have to do for multi-criteria decision making. So this is just another cost graph just to show you that there was a lot of analysis that went into just this one example. And this is showing cost over 30 years for a system. So if you're interested in the data and you want to talk about this example in more detail, we can definitely do that in class, and I'm happy to share that. But really, these slides are just to demonstrate how detailed these analyses can get. So the question that I want to leave you with at the end of this part of your pre-lecture is, here's all this data, right? Here's all this amazing stuff that now tells us about the system, but we want to know, now what? How do we make a decision? So for example, if we're looking at region 1, do I choose a centralized option? Do I choose device number 1 or do I choose device number 2? And so the next thing that we have to do is we have to figure out what we want, and then we've got to figure out how we get what we want from this analysis. So the things that we want are the biggest reduction in exposure. So which alternative reduces exposure to a chemical the most? Which has the smallest environmental impact? And which has the lowest cost? These are the 3 things we want. If we don't know what we want, we can't go forward with multi-criteria decision making. So these became our big goals for this project moving forward. So that's a lot to process. That's really setting up multi-criteria decision making. So take a moment when you finish this lecture to think about, what are some of the things when we set up multi-criteria decision making, we come up with criteria and analyses, what are some of the things that we're going to struggle with as engineers? What are some of maybe the pitfalls that we might fall into? And then the second part of this lecture in our next video is going to talk more about how we take these results that you see here from this example and we make actionable decisions based on them. So I'll see you in that next lecture, and I'm happy to talk about any of this in more detail when we talk in lecture.